So next we're going to talk about the direct comparison test. So basically what we can do is we can take a series that we know the behavior of and compare it to a series that we're trying to test. And under certain conditions, if by comparing to the one we know the behavior of, we can determine the behavior of the one we're trying to test. So um, in this direct comparison test, this A sub n series is the one we're trying to test. So we're testing this one, and the B sub n series is the one we know the behavior of. So that's one that we know what happens. It converges or diverges. Now, if A sub n, the series A sub n, is always less than B sub n, and we know that B sub n converges, then A sub n also converges. Okay? That kind of makes sense. I mean, if every term in the series is always less than a series that we know converges, then it converges. Now, I should point out too, this is for series with positive terms, and that's very important. Okay, so when I say less, it's not negative. So, so again, so we have the series we know, which is the B. We have the series we're trying to test, and if the A terms are all less than the B terms, and the B series converges, then the A also converges. And we can also test for divergence. So if we have a series that we know that diverges, so B is a divergent series, but the terms of our A sub n series are all greater than a divergent series, then A sub n also diverges. Okay, so that's the gist of it. That's how it works. And so what we want to do is find a nice series. That's your B sub n series, whose convergence we know, and we're going to use it to compare to the A sub n series. Okay, so we often use either a P series or a geometric series as our series to compare with. So we're going to choose that as our B sub n series. So let's take a look at example 4 and see how this works. All right, so when I look at this series, and I'm trying to figure out whether it converges or diverges, I first of all just try to make a guess based on my intuition. This is going to converge or diverge. And I see this 3 to the n in the denominator, and I know that that exponential function grows really quickly. So my guess is that this one converges. So now I want to think about trying to find a P series or a geometric series that's similar to this. Now that makes sense that I would use a geometric series because because of this 3 to the n in the bottom. So if I compare it to, say, the series 5 times 1/3 to the n, that's a geometric series. N equals 1 to infinity, right? That's a geometric series. It has an a of essentially 5/3, and then the r value, the common ratio, is 1/3. 1/3 is less than 1, so I know that this converges. Right? That series converges. So that's probably a good candidate for comparison. Okay, so now we know that this, that it has to be positive. So we have to check that this is all positive, and it's true. If n, all these numbers are positive, so any power of 3 is going to be positive, and 3 plus 2, that's going to be positive, over 5, that's all positive. So I know that this series is greater than 0, so 3 to the n plus 2. And I also know that this is less than 5 over 3 to the n, right? Because the denominator 3 to the n plus 2 is bigger than 3 to the n, slightly, depending. I mean, especially for small values, but for large values, that 2 is going to be negligible. But I know that this series is less than this. And this is essentially the geometric series I just wrote. So because I could write this as 5 times 1/3 to the n, right? So, so that tells me that I can compare it to this geometric series, right? So for all n greater than or equal to 1, right? Because all my n's are greater than or equal to 1. So because each term of the series I'm trying to test is less than this convergent geometric series, then I know that this series converges. So I can conclude that, therefore, the series converges by the direct comparison test. Okay. So I should tell you too that your book uses it calls it just the comparison test. I'm using the direct comparison test because there is another comparison test that we're not going to talk about. So that's, I mean, I usually call it the direct comparison test because just to distinguish it from other comparison tests that we're not going to talk about in this class. So I just wanted to make sure you're aware that when I say direct comparison test, it's the comparison test that your book refers to. All right, so there's one example, and I got a couple more examples, and then you'll be ready to try this out in the discussion questions.